Alright, we're going to take a look at transformation. So we're going to look at an overview. So on that page that we wrote our title transformation, we're going to write the following. So transformations from the movie Transformers, which all it means is to change something. So the movie was changing from a car to a robot, a car to a robot. So all the transformations mean is to change something. Alright, we're going to talk about a pre-image. Pre meaning before. And then after you transform it, it's going to be called an image. So an image is after. So if we had a square or a rectangle labeled A, B, C, D, to do the notation for the image after you've transformed it, it will be A prime, B prime, C prime, and D prime. Alright, so the prime right there, prime how many times the image is transformed. That indicates how many times the image is transformed. This is a listening check. Put a box around the word prime. So if you have 1 prime, it means once. If you have 2, it's twice. And if you have 3, it's 3 times. Alright, we're going to break this page up into 4, but what you're going to do is, because it ends up being too much to break it into 4, so break it into 2, like the top and the bottom, and then use the page on the left hand side and break that into 2, top and bottom. And then you're going to label it in order. It goes quadrant 1, quadrant 2, quadrant 3, quadrant 4. It goes in an anti-clockwise. So you're not going to try and make it all fit in this one page because it's going to be too much right in that page. So break this page into 2, the left into 2. Alright, translation means a slide. So if we look at a transformation with a slide, is if you had a rhombus and then you slid it. So let's slide it to the right. Each point moves to the right and then down. So if we slid it to the right and down, it would look like this. So you notice that how it is exactly the same shape, the same size, the same angle, same everything. It's just in a different position. And that's every point that's translated to the right and then down. Alright, so we're just going to write that down. Same shape, same size, same direction. And what that means is it preserves distance and angle measure. This is a listening check. Color only the word preserves. Color only the word preserves. A listening check. Underline the word flip. Only the word flip. The listening check. Color in the holes in both R's. Every point of that R is exactly on the other side of the book. So it goes in perpendicular to the spine, meaning it meets the spine at a 90-degree angle. Alright, so what else do you know? Well, it has the same shape. It is the same size. It's just in a different direction because you can see it's flipped. So that means it preserves the distance and the angle measure of the shape because it's the same shape, same size. This is a listening check. Go ahead and color preserve distance and angle measures. Now let's take a look at notation. How would you see this written down? You will see a small r. Make sure it's a small r. And then you'll see the line of reflection then underneath it, so x-axis. Then you'll see a point, or points. Alright, and that means to reflect the point 3, 2 over the x-axis. which is going to be the spine. So the x-axis is going to be where you draw the spine. And let's take a look at another example. What if you had small r, y equals negative x? Well, that means to reflect the point 32 over the line of y equals negative x. Alright, let's look in the third coordinate. The third one we're going to look at is rotation. Alright, and that means to turn just like a clock. Okay, to turn just like a clock. Again, try to draw this to the best of your ability with it turning. Yeah, I know it's a little bit difficult, but just try to draw it. So what you're going to do is kind of draw it in a circle kind of manner. So I'm going to make part of a circle, and that point keeps turning. This is a listening check. Color in only that triangle. So if I turn my book like a little bit, you'll see how the triangle will keep turning. So if I turn my books, you can't see that. You didn't see that. But anyway, if you turn your book, you'll see it. Alright, so if I turn it about there, it'll look like that at that point. Right there, it'll look around that. It just keeps turning as you rotate it. Right there, it'll look like that. Something like that. So try and draw that to the best of your ability. And then the degrees that it turns right there goes there. So that's the angle of rotation. Like when you're asked how much should you turn the shape. So that's a rotation around a particular point, which looks like 1.5 and 1.5. Most of yours are going to be around the origin though, so it'll be a little bit easier, but that's a rotation through that point, not the origin. Alright, so what can you see? Same shape again, right? Same size. Just in a different direction because it's not standing straight anymore. Alright, and again, what does that mean? It preserves the distance and the angle measure of the shape because the shape has not changed. The angles have not changed. Alright, what does notation look like? Alright, the notation for this one, and be very careful to know the difference between this one and the reflection. The notation is capital R. And then if you had negative, let's say you're rotating it negative 90 degrees, and here's the kicker. Negative 90 is actually in the clockwise direction. So make sure you make a note of that. Alright, so means rotate point 32 clockwise. Okay, and think of how a clock goes. So go ahead and just draw like a little clock. This is a listening check. Put a box around clockwise. Put a box around clockwise. Which looks something like this. And clockwise means to turn it to the right, just the way a clock goes. So the negative is to the right. Negative is clockwise. I know you're going to think it's the other way, but it's clockwise is negative. And sometimes you have an abbreviation with a CW. So if you had R positive 270, that's counterclockwise. So that means rotate the point 32 counterclockwise, 270 degrees. And counterclockwise means to the left. So instead of rotating it to the right, you're going to rotate it to the left. So positive means rotate to the left. I know that's a little bit off, but that's how it is. Just like the quadrants are numbered to the left from the top right, it's the same thing here. And again, the abbreviation of that one that you might see is CCW. Alright, last one in the fourth quadrant, the last rotation transformation we're going to look at is called a dilation, and that simply means to make something bigger, big, or small. So if I had a little triangle and I made it bigger, it would be a bigger triangle. And I'm going to increase this by a scale factor of 3. That means all the sides get 3 times longer. You can see it gets bigger. Alright, so what do you notice? Same shape, right? It's a different size, but it's the same direction. Like it's still standing straight or upright, or however you want to say that. So we said in every single other one that it preserves distance, but this one does not preserve distance because you can see the distance is longer. This is a listening check. Instead of writing but preserves angle measure, you're going to say and preserves angle measure. So it does not preserve distance and angle measure. Capital D. And then there's going to be some small number attached. I'll label it K right now. And that means dilate 0.84 by a scale factor, also written as SF, of k, of some number k. So what that means is basically you will take every single point and multiply it by whatever k is. So if k is a fraction, this is a listening check, circle k, circle k. If k is a fraction, it's going to make the image smaller. If k is equal to 1, it stays the same because anything multiplied by 1 is the same thing. If k is bigger than 1, it makes it bigger, and k can never be 0. Okay, so that's a quick overview of what transformations are. We're going to look at them individually. And again, yours is on both pages. Let's practice.